In this lesson, we are going to learn how to solve systems using elimination with multiplication. So we just learned how to use elimination with addition or subtraction, and that happens when the coefficient in front of a variable is either the same or opposite. But let's take a look at this example where we have x plus y equals 1 and 5x minus 4y equals negative 7. So if we just tried to add these, we would end up with a 6x and a negative 3y and a negative 6. So remember, the word eliminate means to get rid of. That would not get rid of any of the variables. So we have to make the coefficients opposite of each other in front of either one of the variables in order to eliminate the variable. So I'm going to choose to get rid of the y's, which means I have to multiply this top equation by a number to get the opposite of negative 4. The opposite of negative 4 is 4, so I can multiply everything on top by 4, and since I'm doing the same thing to each side, it will result in an equivalent statement. So I get 4x plus 4y equals 4. And then the bottom equation is 5x minus 4y equals negative 7. And now I can do what I learned in my previous lesson. I add these, I get 9x. The 4y minus 4y cancels. And then 4 minus 7 is negative 3. I can divide both sides by 9 now. And x equals negative 1/3. Once I know what x is, I take my original problem, x plus y equals 1, and I plug negative 1/3 in for my x value. Negative 1/3 is x, and now I can solve for y. So I add 1/3 to both sides. That cancels, and I'm left with y equals 1 1/3. So my solution, again, a solution to a system is a point where the two lines intersect. Has to be in the form of xy, so my x value is negative 1/3, and my y value is 1 1/3. I can check this by plugging the x value in for the x value here. So I would get 5 times negative 1/3, and I would plug my y value in for the y here. So I would get minus 4 times 1 1/3, and I want to see if that really does equal negative 7. So I could type that into my calculator. It does work, so that means that this is the correct solution. We're going to do several examples. So let's move on to example 2. In this one, I am given negative 5x plus 3y equals 11, and I'm given x minus 2y equals 2. So if I just try to add as is, I would get negative 4x, I would get a 1y, and I would get 13. So nothing eliminates if I do it that way. So that means I need to choose a variable to get rid of. And it's easy to get rid of the x's because the coefficient in front of this x is 1. And I need it to be the opposite of negative 5, so I need it to be a positive 5, so I multiply everything I see by 5. If I multiply everything by 5, I'm going to copy the top problem down, negative 5x plus 3y equals 11. And now my new equation on the bottom, when I multiply everything by 5, is 5x minus 10y equals 10. When I add those, the x's go away. I have negative 7y equals 1. I'm sorry, that's 21. And then divide both sides by negative 7. So y equals negative 3. Once I have my variable y, I can go back to my original problem. It doesn't matter which one I choose. So I'll choose the bottom one, x minus 2y equals 2. I'm going to plug y equals negative 3 in. So then I have x minus 2 times negative 3 equals 2. X minus negative 6 equals 2. Remember that minus a negative becomes plus a positive. So that's x plus 6 equals 2. Subtract 6 from each side. So that leaves us with x equals negative 4. So my solution in the proper form is negative 4, negative 3. Remember the x comes first. If I do a check on this, I'm going to plug negative 4 in for my x. I'm going to plug negative 3 in for my y. So the result will be 20, negative 5 times negative 4, plus 9, 3 times negative 3. I'm sorry, negative 3 is negative 9. So 20 plus negative 9, does that equal 11? Yes, it does. So that means that it did check, so the solution is correct. Let's try a third example. Example 3 is negative 5x plus y equals 35, and 3x plus 2y equals negative 21. So we have to eliminate one of the variables. Since my coefficient in front of the y is 1, I'm going to choose to get rid of the y's. I need opposite coefficients, so I need to multiply the top by negative 2 to get the opposite of positive 2 here. So when I multiply everything on the top by negative 2, I would end up with a positive 10x plus negative 2y equals negative 70. And the bottom one stays the same, 3x plus 2y equals negative 21. When I add these, I get 13x. Negative 2y plus 2y cancels out, so that's why we call it elimination. And over here I get negative 91. Divide both sides by 13, and we get x equals negative 7. So once we have our x value, we could plug it back in to one of my original equations. So my original equation was negative 5x plus y equals 35. So I'm going to replace the x with negative 7. So negative 5 times negative 7 plus y equals 35. So I get 35 plus y equals 35. Subtract 35 from each side, and we get y equals 0. So my solution in the proper form is -7, 0. The x comes first and then the y. So when we have this, we can check in the other equation. So my x value is -7, my y value is 0. So it's 3 times -7 plus 2 times 0, and we want to know if that equals -21. So that's -21 plus 0 equals -21. That works, so I know that my solution is correct. All right, now we're going to do a little bit different type of example. This is example 4. And with this one, we are going to have 4x minus 5y equals -28, and -9x minus 2y equals 10. Now we run into a problem because there's no way I can get opposite coefficients by multiplying one of the equations by a number. So when this happens, we can take the coefficient in front of each number. So I'm going to choose my x's. My coefficient in front of the x is 4, and it's also -9 down here. So what we want to do is we multiply the top row by -9 and the bottom row by 4. Look what happens when we do that. So the top row, I'm going to multiply everything by -9. Multiply everything by -9. So that results in -36x plus 45y equals 252. Then I'm going to multiply everything on the bottom by 4. So multiply everything by 4, and we get a -36x. So I just realized what I should have done, instead of multiplying the top by -9, I should multiply by +9. So let's go back and fix that. Multiply everything by a +9. So that means that it's +36, it's a -45, and it's a -252. All right. Now I'll tell you why I realized I was wrong in just a second. Multiply the bottom by 4, so we get -36x. And the reason I knew I was wrong before is that I had two negatives and they won't cancel. So let's continue. We have a -8y, and then we have a +40. Now, since these two coefficients are negative and positive, they cancel out. -45 plus -8 is -53y, and -252 plus 40 equals -212. Divide both sides by -53. And we get y equals 4. Alright, so once I have y equals 4, I go back to one of my originals, doesn't matter which one, so I will do 4x minus 5y equals -28. That was one of my original problems. Plug 4 in for the y, So I have 4x minus 5 times 4 equals negative 28. 4x minus 20 equals negative 28. I'm going to add 20 to both sides. So we get 4x equals negative 8, and divide both sides by 4. We get x equals negative 2. So that means that my solution is negative 2, 4. The x comes first and then the y. So let's just make sure that it works in my second equation here. So I have negative 9 times my x value, negative 2, minus 2 times my y value of 4, and I want to know that that equals 10. So we get 18 minus 8, and that does equal 10, so I know I'm correct. Alright, so we will be practicing solving systems using elimination with multiplication in class. What I would like for you to do now is try this problem with a basic elimination by multiplication, and in your Google document you will be asked to write your answer. So here's the equations. On Google Docs, what I will be asking you is what the y value of this problem is. So try to use the elimination method with multiplication and see if you can figure out just the y value. And your Google form can be found at this address. The Google form is bit.ly/elimination with multiplication. Please go to that website and answer the brief questions.